The first part of this question asks us to explain what a weak base refers to. Bases tend to generate hydroxide ions in aqueous solution. Strong bases generally dissociate or break apart into ions and generate hydroxide ions, while weak bases generally react with water and produce hydroxide ions. The important difference is that for equal concentrations of a strong base and a weak base, the strong base will dissociate completely and generate a high concentration of hydroxide ions, while a weak base dissociates or ionizes only partially, forming an equilibrium, and generates a low concentration of hydroxide ions. So strength refers to the degree of ionization, and again we would have to compare equal concentrations of a strong base and a weak base, and we can see the concentrations of ions produced differs. It is worth committing to memory the formulas and names of the common strong acids and bases, and the common weak acids and bases. Next, we have to take the carbonate ion, which is found in the weak base potassium carbonate, and we are asked to find its conjugate acid formula. According to Bronsted Lowry acid-base theory, an acid is a proton donor and a base a proton acceptor. So the acid donates or gives a proton, which is a hydrogen ion, to the base. And these are the general formulas of the products. The conjugate acid product differs from the base by 1 proton, and the conjugate base product differs from the acid by a proton. These two are a conjugate acid-base pair, and these two are a conjugate acid-base pair. So the carbonate ion, which is a base, must accept a proton to form its conjugate acid. The conjugate acid of the carbonate ion will differ from the carbonate ion by a proton. So the conjugate acid of the carbonate ion is HCO3-, which is called hydrogen carbonate. Since the carbonate ion had a 2- charge, when it gains a positive proton or a positive hydrogen ion, it ends up with a 1- charge.